All right, so in 12.2, we're going to be adding and subtracting polynomials. Yesterday, we kind of learned a little bit more about what a polynomial is. Basically, it's a term, but then it's multiple terms within the expression. All right, so we've been looking at these all year, but now we're looking more specifically at like terms. So now they have exponents, like let's say 2x squared plus 2x squared. Well, now they're both x squared, so I can add them together. But 2x to the fourth and 2x squared, are those like terms? 2x to the fourth and 2x squared? They're not like terms. Even though they both have an x, they're not like terms because they have different exponents. All right, so that's some of what we learned yesterday. Well, we're going to build right on top of that today. All right, now yesterday we already started kind of simplifying those like terms. That's basically what we're doing today. All right, and I'm going to teach you how to do it vertically and horizontally. End of the day, I don't care which one you choose. I prefer horizontally. Ms. Houlihan prefers doing them vertically. It really comes down to preference, okay? Don't care which way you do it as long as you get the correct answer. So if I'm adding polynomials vertically, I start with the first set, and I'm going to just rewrite it. Negative 8x to the third plus 4x squared plus x plus 1. All right, and I have those numbers. And then the numbers in the second set, I'm now going to filter under the numbers in the first set under their matching like terms. Okay, so let's start with the first term, 3x to the third. What term in the first set would I put it under that would be its like counterpart? Negative 8x to the third. Very good, because they're both x to the third. What about negative 2x squared? Where do I put that one? Under 4x squared.
I apologize for the interruption.
Okay, so negative 2x squared goes here. Any x's to put under the x? So I'm just going to kind of fill that in with a 0 just to kind of hold the place so I keep everything lined up. And then the 7 would go under the 1. So now that all of my like terms are lined up, I'm just going to simplify the coefficients. All right, so negative 8 plus 3 is? Negative 5. 4 minus 2 is 2x squared. And then I just bring down my x, because there's nothing to add or subtract from it, plus 8. And conveniently, it's already in standard form, descending order, so that's my final answer. All right, so a lot of people like the vertical way because I'm lining up my like terms and I can see everything, and you know, they like doing it that way. All right, so now let's look at horizontally. All right, let's see. Okay, so the horizontal method, I'm kind of just leaving it, and in your book they write them all horizontally too, but I'm just looking at it the way that it is here. So for a lot of you that like doing mental math, or you know, you don't want to have to rewrite again what's already there, you can just look at and pull off with your eye the like terms. 2x squared plus 3x squared would be what? What's 2x squared plus 3x squared? It's just 5x squared. All right. Your book also says that you can group them together, rewrite them. You could do that, I guess, but I mean, can we just assume that we can all recognize that 2x squared and 3x squared are positive and we add them together? Okay, so that's going to be 5x squared. All right, and then I've got my x terms. So I have x and negative 7x. And what's 1 minus 7? Negative 6. So negative 6x. They might be better at math than I can. Negative 6x. And then what about 10 minus 2? 8. Plus or minus? Plus 8 or minus 8? Why plus? Yeah, 10's bigger. 10's the positive number. 10 minus 2 is just 8. And again, it's already descending order, standard form. That's my final answer. So, you know, some of this you can do mental math, but you've got to be able to kind of mentally group your like terms. All right, so we might not be ready for that quite yet. It just kind of depends on how well you can recognize your like terms. All right, so now I want you to do this one. All right, you just kind of ignore what's on top. I don't care if you use the vertical method or the horizontal method. Go ahead and find the sum of this polynomial. Go ahead and add and subtract the terms. Okay, so horizontal method, I kind of prefer that. All right, I group my like terms, negative 5y to the third plus 2y to the third. And again, you can kind of pull this off and do it mentally, but I'm going to go ahead and write it out. Plus 6y squared. Is there any other y squareds that I can match it with? No? Okay, minus 2y minus y. So now I can combine my y to the third terms, and I get negative 3y to the third plus 6y squared, can't combine it with anything, minus 3y. Did you get it right? Yeah? Who got it right? Raise your hand. Who got it right? Okay, one more. And again, here, let's do this one. No, we already did that one. Did we do this one?
Yes. Yeah.
Yeah, we did that one. So let's do this one then. All right. So again, vertical or horizontal, doesn't matter. Go ahead and simplify. Your answers? Okay, is there anything I can combine with negative w to the third? Nope, there's no other third power. What about to the second power? There's nothing to the second power. Plus w, but can I combine my numbers?
Yes.
Minus 3. All right, who got that right? Okay, much more. Good, good, good. Now, with subtracting polynomials, there's a rule that you have to know. You can subtract a polynomial by adding its opposite. Adding its opposite. So you're going to actually change the signs of every term inside the second set. To find the opposite, multiply the terms by negative 1. But what am I doing? I'm just reversing the sign. If it's positive, it's now negative. If it's negative, it's now positive. All right, so you're adding the opposite. You don't have to write down every single word, but you do need this first line. You can subtract a polynomial by adding its opposite. Okay, so subtracting polynomials. There's a subtraction sign now in between my two sets of terms. So what do I do with that? I am going to change it to an addition sign and now reverse the sign of every term inside the parentheses. So now 2x squared is negative, x is positive, and 8 is negative. And I'm going to rewrite it. Okay, so not a bunch of those squiggle marks. I'm actually going to rewrite it. 6x squared, am I supposed to be doing this vertically? Okay, plus 4x minus 7. And now when I write its matching term underneath, I write it with its new sign. So now 2x squared is negative. Negative 2x squared. X is positive and 8 is negative. Do you guys see how I reverse the sign? And that's just my rule. There might be some kind of reason behind why we switch the sign. I don't know. We just need to accept it at this point and just know when I'm subtracting polynomials, sets of polynomials, I add the opposite. I reverse the sign of every term inside the second set, and now I simplify. 6 minus 2 is 4, x squared plus 5x minus 15. Okay, so now I want you to do this one. You can set it up. Go ahead and try to set this up vertically. Since we're, kind of learning both ways, go ahead and set this up vertically. All right, so when we set this up vertically, we go 5a to the third minus 3a squared minus 7a. Now, you can mental math, you can change these out. You just have to remember, all right, everything inside the second set, I have to add the opposite. So I changed this to an addition sign, and now 4a to the third is negative 4a to the third. Negative a squared is now positive a squared, and 5a is now negative 5a. And now you can simplify to a to the third minus 2a squared minus 12a. Who got it right? Who got it right? Raise your hand if you got it right. So now let's look at horizontally. Okay? So horizontally, I'm just going to match up my common terms again. So, but remember, we have to add the opposite of every term inside the second set. So now it's x squared minus 4x squared plus 5x minus 11. Do you see how I did that? Oh, I forgot my 9. I'll just write it at the end. Minus 9. Wait, hold on a second. What did I do? X squared. No. I messed that up. X squared. I'm matching up my terms. So minus 4x squared plus 4x. Okay, so I add the 4x. Now I match up my positive 5x. I have to do the opposite sign. Plus 5x minus 9 minus 11. Because remember, I do the opposite sign in here. All right, and now I can just combine them. X squared minus 4x squared is negative 3x squared plus 9x minus 20. You just have to remember to do the opposite, to add the opposite of whatever sign is in the second set. Okay, so I'm going to set this up vertically. You could do it horizontally, but again, because I'm subtracting, go ahead and reverse all of your signs. So now it's negative 5x squared, negative x, and negative 9, so you don't get confused. 6x squared plus 4x minus 7, and now fill in your like terms underneath from the second set, minus 5x squared minus x minus 9. All right, and now we can combine our like terms. X squared plus 3x minus 16 is our answer. All right, and who got that? Okay, more. Good. All right, guys, that's everything you need to know for 12.2, adding polynomials.